So we want to imagine a thought experiment of having a spherical shell of matter, empty inside, just a shell on the surface. And I need to know what the gravitational field of that looks like. And it was calculated by Newton. It's in his Principia. So I'll just tell you the result. Many of you, I'm sure, know this. And if you don't, you'll just have to believe me. The result is that outside the shell, the gravitational field is exactly what it would be if the whole mass of the shell were just a point mass at the origin, just a 1 over r squared force. So these force lines shown outside are supposed to represent that. Inside the spherical shell, the gravitational field is exactly 0. It cancels out in the different directions. So the sum, when you add up the force due to the attraction to each bit of mass around the shell, adds up to exactly 0. And Newton figured that out, too. So now what I want to do in my thought experiment is to imagine that this shell is made out of something flexible, putty of some sort, clay, so that I can allow it to collapse under its own self-gravitational force. There'll be a force on the shell pulling inward. Every particle in the shell will be pulled by the other particles of the shell, and the net force will be inward on any particle of the shell. So I want to take advantage of this inward force